Okay, just a few things to say about our testing for aldehydes and ketones here. So this was the reaction with the 2,4-DNPH, so the 2,4-dinitrophenylhydrazine. Now, in an old specification, you used to be able to, or used to have to be able to draw out the structure that was produced when the two things reacted together. So those of you who've been in school will have seen that you get a yellowy, orange, reddy precipitate. And if you haven't been in school, then we will show you in the future, you will have to go at producing this precipitate. Now, there was a recent exam question since the new specification, so since your specification, which actually did have this question on. So strictly not on the syllabus, but from the information that was given, you can apply your chemical knowledge just from a kind of chemical common sense perspective, and then you can work out what's going to happen. So the question was something along the lines of, when these two things react together, so the 2,4-DNPH and your carbonyl compound, a condensation reaction happens, draw out the proposed product. So you have to think, right, a condensation product. So we've got a condensation reaction, so it means that we're removing water. We're removing water, and the product has to be unique to the specific carbonyl compound you started with, because we've said you can look at the melting points, and then the melting point will tell us what the carbonyl compound was. So if the product is going to be unique to the original carbonyl compound, let me get a red that will show out nicely. Now, all carbonyl compounds contain this, but the specific starting carbonyl compounds will have unique R groups. So basically this chunk here is the bit that needs to be bonded on in order to be specific to a specific carbonyl. The C double bond O bit could be anything. So if we're going to lose the O from over here, then we must have water formed. So we must lose two H's from here. So have a good look around. Two H's, lo and behold, two H's. Kind of convenient. So what about if we take out that water molecule? So we need to make sure that everything ends up with the right number of bonds and so on. So here's a Blue Peter one I started drawing out earlier. Okay, so we've got the top of the structure here. So we've got to, I've just drawn out the NH already. So we've now just got the N. Because the two bonds to the hydrogen are no longer, oh gosh, I've drawn out an H as well. Let me just scrub that out. I'll find my Tipex in a minute. Because the two bonds to the hydrogen have, we've no longer got the hydrogens there, so they're gone. Let's do the Tipex. It's all nice and tidy. There we go. And then the oxygen's gone as well, because that went off with the nitrogen, the hydrogen. So then our nitrogen presumably is going to be bonded onto the carbon. So this carbon has two bonds here already. It had two there, so it needs two more. This nitrogen was bonded to two hydrogens, so it needs two more bonds. So that's nice and convenient. We can draw a double bond between the two of them there. And then we've got our R groups. And that means that this product is going to be unique for each of the different aldehydes or ketones because of the R groups. And so that is a sensible proposed product that could be formed by the condensation reaction, so the removal of water when you react the 2,4-DNPH and the aldehyde or ketone. Okay, so it's just kind of being sensible. You don't need to know anything about how they react. You just need to use a bit of logic. Think, right, I'm removing water, so I need to take two H's and an O from somewhere. We're linking the two things together, so obviously they've got to bond together. And the product has got to be kind of keep some of the structural integrity, if you like, of the aldehydes or the ketones, the original carbonyl compounds. So it's going to have to hold on to this bit, whereas the C double bond O is common to all of them. Okay, so a question that we didn't know anything about, we hadn't learned about this, but just from a bit of chemical problem solving, we can come up with a sensible solution.